given. Okay, this is our cross section of our model. Yeah, so basically the whole amount is for the light from the sun to enter the box. After that, the lens will magnify the light rays and they will hit onto the mirror, which will reflect to this surface. Yeah, to the paper. And there's a hole for the other side to observe the image on the paper.
So the diameter of the pinhole is based on the equation, which is the wavelength of light, square of wavelength light times the length of the pinhole from the screen.
Can you explain the equation? I mean, don't read off. We can read off. Explain why. What does this even describe?
Yeah, what is the
It
D?
is the optimal diameter of the pinhole.
As in why? As in, is this a diffraction limit? Is this what? As in, why 1.9? Why not 2.1? Why is it a square root and not a cube root? As in, what is this relationship in the first place?
We're not very sure.
Then, if you're not very sure, how can you use it? Might as well guess a number. So you must be able to explain why you use this. Oh, sorry, yeah, set force. We are asked to ask set force.
Do you know what are the D, F, and lambda first? What do they represent?
The wavelength, the length of the distance from the pinhole to the screen where you the object. In this case, it's the lens.
Well, lambda is wavelength. So from your calculation, I deduce to assume lambda is 255 nanometers. But the problem is 255 nanometers is ultraviolet light. So I'm not sure how we can see that. Our human eyes can see minimum is 350 nanometers to 810 nanometers. We can't see that. That's invisible to the human eye. So why do you use that value?
And also the dimensions are wrong. F lambda should be...
In the calculation, you can use cm times nm. Nanometer is 10 to the power negative 9. So do you convert everything to the same standard metric when you calculate?
Just use the online calculator.
Because intuitively, nanometers is 10 to the power of negative 9. So in the calculation with a 10 power negative 9, how can your final answer still be in the order of mm? It appears to be off by on the order of 1004 or so. You square root 10 power negative 9, this thing is about 10 negative 5. So you are about 100 to 1000 times off in your final answer. I think I could be wrong.
Yeah, I think something wrong. 0.34. Wait, can you show on your cross section where is D?
Yeah, on the cross section where
is D? Yeah.
So when the top view, the one on the right hand square, it is supposed to be, there's a pinhole.
Oh, so the diameter
of the aperture of the hole lah. Oh. The hole of the how wide the hole is.
So D is the diameter of the hole.
Because we can't get the exact. Then we have the lens 6 cm away from the hole. 6 cm is also using
This is very suspicious. Wow.
So the lens magnifies the image and then you can
6 cm is 0.06. 0.06 meters times 255 times 10. What's the power button?
But anyway, you should also include the source where you get your equation from on the website. So that will increase your credibility as well.
Power 0.5 times 1.5.
So what's F? Is F the focal length of the lens or the distance?
the focal length of the pinhole as the lens.
0.2
It's the length of this would be the pinhole as the lens.
Oh, the separation between the pinhole and the lens as...
Surface, because normally you can see this way.
Oh, okay. I think I'm missing it. Is it correct?
The order is correct. It's slightly off, but the order is correct. They need this point. But I don't understand why this Is.
The F is not focal length, man. The F is the distance between the hole and the lens. Yeah.
Okay, there's a marker there. Can you just draw out the relationship DF lambda thing? There's a marker and there's a whiteboard.
I don't know how this came about, but this is the.
My first suspicion was radian criterion.
Yeah, it is really criterion.
But radian criterion is 1.22 sin theta lambda over d. Lambda over d, if I substitute over 1.22, then what is 1.9? Okay, sin theta you can approximate to this, but 1.9. I also don't know. And where did the square root come from?
Yeah, so we can show what's D, what's F, and what's lambda.
This is so this is the whole this is E. Then here's the whole, here's the lens. So this is
Hey, the rest of the group, just because it's not your project, you should pay attention also. Oh, sorry.
The groups who ask questions now will ask you less questions later. Those who keep quiet will ask a bit more. You can represent, huh? Okay. No, I just realized we're doing two thinking what's happening here.
Okay, so continue with your presentation. Or you finish already?
pretty much
Okay, so how big was the hole that you measured?
You should, do you bring your...
use a steel pin, so it's around 1 cm. We couldn't really get it.
Okay, so about 3-4 times larger, fine. Okay.
Do you want to show around, give your fellow classmate your demonstration of your product? Or you just leave it like the next shop and let the consumers come and touch?
It's not really, and
You should go around and show them.
use a flashlight on this one.
No, seriously ask.
I think we use the intensity is we're not looking at the sun already. The image is projected onto a piece of paper. We're looking at the piece of paper. Can you use lenses of the interfocal type? Sorry, can you use lenses of the interfocal type? Or this one is just we use a lens of 5 cm just because this is the smallest possible. Can you use like let's you can use it like the body has to be stable. Just it. The level is higher.
So they use
50 mm.
size focal length.
Sorry, apart from all the measurements that I do not understand, but the practicality of your instrument, that you will be blocking everyone who's behind you with this. And if we all of us have this, then what else is going to be? Is there any way that like doesn't have to be that long?
We got a lens of different focal lengths, so I don't think we have any other smaller needles. So this is one that we use.
Also, if you would have a different lens, then
Probably still have that. Yes. If you press the image on the paper, you will hit on the side cause a problem. Cause problem small.
Will it burn up? I think that's the question.
The lens is not for using this, for minimizing image. But you're not looking at the sun. you're supposed to look at the image of paper. Yeah, but I saw I see a small circle. Yeah, that's but because if this is the image, so I can see the sign. You saw the image of the mirror. I feel like if it's on paper, then it wouldn't really see, because you can really see a small circle because we so this is no intensity. So I can see the sun because sun is much more. It wouldn't get it because you're not looking at the direct. It's not focused enough to burn the paper. You can see it, yeah, that is because the lens is not very properly aligned. You see a colored block because it is
Roughly what size of the image of sun do you expect? Roughly. I mean, because you say it's not so focused, it's slightly magnified, so you must be able to give a feel. Should we expect a 1 cm this 10 cm? Roughly how do you reach the 3-4 cm? Any numbers other than pure feeling? Because I mean, if you want to convince anyone to pay money for it, you need slightly more than I believe you will pay money. So if you have a sun that is 3 cm wide, how wide do you expect the Venus dot to be?
3 cm wide.
Okay, because I mean, how wide do you expect the reflected image of the sun to be? About 3 cm, roughly. Okay, so how wide will Venus be? It's about 100 times smaller. So 3 cm divided by 100 times is 0.3 of an mm, which is, as you pointed out, thinner than a pin. Yeah.
But then they can rely on the zoom of the video.
Then need magnifying glass as well. Oh, okay.
Then how do you tell apart the ants or from the Venus? Let's say an ant crawl across the sun.
The ant will be bigger. To be fair, I think this thing is almost there. The one thing that's missing is if you can determine your magnification and choose in a more detailed manner the focal length of your lens such that you can get maybe 5-10 cm maximize. I mean, this thing is what 9 cm wide, maximize it, then it will be nicer. Other than that, I think it's okay.
Because I think in the past, in the 1600s, the astronomers also used this method. They use the telescope and then they project the image onto a screen. That's how they circumvent the problem.
And of course, if you have a disc that's 9 cm wide, then the burning part is not an issue anymore. Because you have dispersed light, I don't know, 10 cm square or 100 times more dispersed is not an issue. And in terms of user friendliness, to be fair, it's also okay. Because if the sun is up there, everyone point up. You are not blocking that view, so okay. Other than the lambda.
Yeah, the equation is a bit strange. Actually, there shouldn't be a square root, you know. It should be like 1.22.
Sin theta equals to lambda over d, where lambda is equals to wavelength of light. You're looking, d is the aperture diameter.
Yeah.
Then sin theta is in radians. Then you do the far field approximation, sin theta equals theta. Okay, never mind. Sorry.
Okay, thank you. Back to English now.